Hello guys, so we are back again, and in this session we are going to continue with the new topic, which is legendary differential equation. And if you remember properly, in the last session what we had did, we completed the Cauchy differential equation, and now we are on the last topic of this chapter, right? So let's begin with the last topic, which is legendary differential equation. So the topic is legendary differential equation. This is just a modification of Cauchy differential equation. If you understand the Cauchy differential equation, you will easily understand this topic. It is just just a little bit modification in Cauchy differential equation. Okay, whenever you see a differential equation of the form, okay, differential equation of the form what form? If the form is like this: ax plus b the whole cube d cube y by dx cube plus p1 ax plus b the whole square d square y by dx square plus p2 ax plus b into dy by dx plus p3 y equal to q of x, where p1 p2 p3 are constants, right? Are constants, is called legendary differential equation, right? Keep this in mind. Now if you remember the Cauchy differential equation, there was x instead of this. So the only thing difference you will observe is the equation format is same, but instead of x it is replaced by what? It is replaced by ax plus b. Now let's see what substitution we have to do to convert it into higher order linear differential equation with constant coefficient. So to convert it to higher order linear differential equation with constant coefficient, what we are going to do, we are going to do a substitution, which is called, we will substitute ax plus b as e to the power z, right? Now what we are going to do, like in the previous we substituted x equals to e to the power z, we will move this e on that side, log ax plus b we will get equals to z. Now if I differentiate, I'm going to get a by ax plus b equal to dz by dx. Now what we need to find dy by dx, like there I needed to find dy by dx and got x dy by dx. So what we are going to do, we are going to multiply and divide by dz. Then I know dz value, I can write it dy by dz into this thing, a by ax plus b. So what I'm going to do, I'm going to move ax plus b on that side. So ax plus b into dy by dx equals to dy by dz into a. Now we will call this d by dz as d. Okay, we told that d by dz is called d. Okay, in different books they call it d naught, okay, mu naught, okay, whatever they like, but we are going to call it d. So a dy, right? So we are writing it like this. So we got like this. Now if there is second order, then what we are going to do, we are going to do a simple thing, we are going to modify the equation a little bit. Just see, if there is d square y by dx square, like there it was in Cauchy differential equation, what we did, so what we are going to do, d by dx into, it is nothing but dy by dx, if you remember. So what we are going to do, we will substitute the dy by dx value. From where we will substitute the dy by dx value? From here. We know it is nothing but a upon ax plus b into dy by dz. So we will substitute here. D by dx is nothing but a upon ax plus b into dy by dz. Agree? Now we will multiply, apply the product rule of division, differentiation. A by ax plus b into d by dx of dy by dz. Agree? Now plus, we are going to keep this as it is, dy by dx. We are going to differentiate d by dx into a by ax plus b. Agree? After this, if you know, we only know dz by dx. If I want to create here dz by dx, what I am going to do, I am going to take this dz outside, a by ax plus b. Okay, and I am what going to do, I am going to multiply and divide by dz again. So just see what we are going to do. D by dz into dy by dy by dz. Okay, dy by dz, dy by dz into dz by dx. Right? So what I did, I moved the dx. Okay, I multiplied and divided by dz. Okay, and move this x here. So I already know dz by dx value, which is nothing but a by ax plus b, and here I will apply the quotient rule of differentiation, which will give me ax plus b, and if you notice here, I will get minus a square. Okay, now if I simplify, substitute the value a by ax plus b into d square y by dz square into dz by dx value I know, a by ax plus b. Here dy by dz as it is, minus a square by, here square will be there, ax plus b the whole square. We are going to, here also a square upon ax plus b the whole square will become, so we will take it outside. So we are left with d square y by dz square, and here outside a square is there, minus dy by dx, and we have moved the ax plus b the whole square this side. So you can clearly make out that we got whatever thing we wanted, that is, we wanted to get this value ax plus b into d square y by dx square, which we got. So we substituted d by dz as d. So if we substitute here d square y minus dy, so if I take outside a into d and y take outside, I will be left with d minus 1. So here we are getting actually d into d minus 1 into y. So everything is same, except we have to multiply here by a, whatever coefficient of x is there. So similarly we can prove for ax plus b the whole cube d cube y by dx cube. You can automatically tell, here it is a square, sorry, a square I forgot to write here, I forgot to write here. Now here it will be a cube into d minus 2 into d minus 1 into d into y. Okay, so we have proved whatever we have to replace to convert it into higher order linear differential equation with constant coefficient. Now we are going to take quotients and then we will substitute there and make you better understanding of this. Now let's move on to the question. So the question which we are going to take here will be as follow. The first question is this. The question says 1 plus x the whole square d square y by dx square plus 1 plus x dy by dx plus y equal to 4 cos log 1 plus x. Now here you can clearly make out that it is nothing but legendary differential equation. So I am going to write first question with proper order, okay, everything properly, and from the next question onwards we are going to write whatever important is there. So given differential equation is legendary differential equation, to convert it into linear differential equation with constant coefficient, we put 1 plus x equals to e to the power z, because here instead of ax plus b it is 1 plus x. So what we are going to do, we are going to move this here, so we will get log 1 plus x equals to e to the power z, sorry, as z. If I differentiate, I will have 1 plus x equal to dz by dx. Now if I want to get dy by dx, it will be nothing but dy by dx, dy by dz into dz by dx. Agree? We know dz by dx value, so it will be dy by dz into 1 by 1 plus x. Agree? We will move this on that side. So 1 plus x into dy by dx is nothing but dy by dz, which we call dy. So we got this thing. Now similarly here our a is what? 1. That's why we are not writing it 1. Similarly 1 plus x the whole square d square y by dx square is nothing but d minus 1 into d into y. So after getting this, okay, you can write thus given differential. This all the statements will be similar to Cauchy differential equation, with just one twist, that here whatever polynomial ax plus b or whatever linear function you have ax plus b, you will write that. So the given differential equation becomes, it will become what if I substitute d into d minus 1 into y plus d into y plus y equal to 4 cos. And now you know we have to substitute everything when we convert into linear higher order differential equation. What we do, we substitute every x into z. So for that we should use this first and second equation. So here log 1 plus x is nothing but z, so here I will write it cos z. So we got this thing. Now if I simplify them, I will get the final equation as d square plus 1 into y equals to 4 cos z. Right? Now auxiliary equation is nothing but m square plus 1 equal to 0. If you do that, you will get m equals to nothing but plus minus iota as the roots. Now complementary function is what? If I want to e power 0z, because here the real part is 0, so here it will be c1 cos z plus c2 sin z. Now you know when we write the complementary function in general solution, we have to write the final answer in terms of x only. So we are going to substitute the value of z. So cos z is nothing but log 1 plus x, in this case c2 sin 1 plus x, log 1 plus x. Okay, now in e to the power, when we were doing Cauchy differential, it was very easy. There was only one substitution, x equals to e to the power z, but here the substitution will vary, so you have to be careful while substituting. Now we got the complementary function. Our target is to getting the particular integral. If we focus on getting the particular integral, you know it will be 1 by d square plus 1 into 4 cos z. Now if I know the moment I substitute here in this type of problem, when sin ax plus b or cos ax plus b is there, I told you we have to substitute d square by minus a square. So here you know it will be minus 1, so it will become 0. So what we do, we differentiate, multiply in the top by x and differentiate, but here instead of x we will multiply by z. So z by 2d into 4 cos z. So what we are going to get, we are going to get 2z cos z by d, and d is nothing but integration, so we will integrate it. The moment we integrate, we will get sine z. So we got this thing. Now we know particular integral should not be in terms of z, it should be in terms of x. So we are going to replace the values. You know z is nothing but log 1 plus x, while sine z will also be in terms of log 1 plus x. So you got the particular integral. Now you can write the general solution. Okay, general solution, which is equals to complementary function plus particular integral. Right? So what we are going to get, we are going to get something like complementary function is what? Complementary function is nothing but complementary function is here, c1 cos log 1 plus x plus c2 sine bracket log 1 plus x, right? And our particular integral is nothing but, I will write it down, 2 log 1 plus x into sine bracket log 1 plus x. Agreed? So we are getting this as our answer. Now let's move on to the next question. So the next question which we are going to take in this topic is this question. We are going to concern with whatever important. So I'm going to just speak the statement. The given differential equation is a legendary differential equation. To convert it into linear differential equation with constant coefficient, put here the coefficient ax plus b is nothing but x minus 1. Okay, so these type of Cauchy differential equation, these are very easy to identify compared to type 6, okay, type 7, okay, which had two methods, partial and all that stuff. It is difficult to identify, I agree, but these last two types, okay, Cauchy and legendary, are very easy to identify. So here, to convert into linear differential equation with constant coefficient, we will substitute x minus 1 equals to e to the power z. X minus 1 equals to e to the power z. After this, log x minus 1 equals to z. Okay, all these substitution are very crucial because you are going to substitute z by this when you need to get the final answer. If I differentiate this, x minus 1 equals to dz by dx. Now to get dy by dx, what we are going to do, dy by dz into dz by dx, we are going to substitute dy by dz into dz by dx value I know, x minus 1, I will move this that side, so I got x minus 1 into dy by dx as nothing but dy by dz. Agree? I got the value which we call dy. So I got, similarly we can say x minus 1. Here we are not getting any a because here x coefficient is again what? It is 1. d square y by dx square will be nothing but d into d minus 1 into y, and similarly x minus cube by d cube y by dx cube will be nothing but d minus 2 into d minus 1 into d into y. So if we substitute the given thus the given differential equation becomes what it is going to become, d into d minus 1 into d minus 2 into y. Firstly 2d minus 1 into y, and then minus 4d into y plus 4y equal to 4z. Agree? So we are getting this thing. After this, if we simplify them, we are going to get d cube minus d square minus 4d plus 4 into y equals to 4 cos z. Agree? So after this, we are going to get the auxiliary equation. Auxiliary equation is nothing but m cube minus m square minus 4m plus 4 equal to 0. And if you simplify this, okay, by hit and trial, you will come to know, or by taking m square common here and taking here minus 4 common, you will easily able to convert it in the format of like this: m minus 1 and minus 4 m minus 1 again. Okay, now you can convert it into m minus 1 into m minus 2 and m plus 2. So I did this step also. M equals to 1, 2 and minus 2 are the roots. So after getting the roots, it is very easy to get the what? To get the complementary function. The complementary function CF will be nothing but, first it will be C1 e to the power z, secondly to C2 e to the power 2z, C3 e to the power minus 2z. Now we know our final, when we write the complementary function, it should be in the terms of x. We are going to substitute e to the power z by x minus 1. So C1 x minus 1, C2 x minus 1 the whole square, C3 x minus 1 minus power minus 2. So we are getting this thing as our complementary function. Now what we are concerned with, particular function. Now particular function will be what? It will be nothing but, if we write the things, it will be d cube, with this equation, okay, d cube minus d square minus 4d plus 4 into what we have, 4z. What is the lowest power here? It is nothing but a type of polynomial type, where it was f of dy equal to q of x, where q of x was nothing but a polynomial function, where we used to take the lowest possible common term outside and then use the Maclaurin series of expansion. So if we take 4 outside, we are going to left with 1 plus d cube minus d square minus 4d by 4 into 4z. So 4 will get cancelled out, and if I do the expansion, 1 minus d cube minus d square minus 4d by 4 plus dot 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 into z. I know the polynomial power is nothing but 1, so here we are going to consider this one only, which will be nothing but 1 plus d into z, which will give me z plus dz, which will be nothing but z plus 1. Now if I resubstitute the values, I am going to finally end up getting z is nothing but log x minus 1 plus 1. So this is the required thing which we are getting. Now if I move on and try to get the final answer, which will be nothing but general solution equals to complementary function plus particular integral. If I substitute the things, I am having c1 x minus 1 plus c2 x minus 1 the whole square plus c3 x minus 1 power minus 2 plus particular integral log x minus 1 plus 1. So we are getting this as our final answer. Now let's take one more problem. So the problem which we are going to take in this is this one, which is 3x plus 2 the whole square into d square y by dx square plus 3 into 3x plus 2 into dy by dx minus 36y equal to 3x square plus 4x plus 1. Here the given differential equation is a legendary differential equation. To convert into a higher order linear differential equation with constant coefficient, we are going to substitute 3x plus 2, which is ax plus b e to the power z, giving me log 3x plus 2 equal to z. Okay, differentiate it. 3x plus 2 by chain rule, here 3 will be there, here dz by dx will be formed, right? After this I need to get dy by dx. What I am going to do, write dy by dz into dz by dx. Agree? We are going to substitute the value of dz by dx, giving me dy by dx equals to dy by dz into dz by dx is nothing but 3 by 3x plus 2. I will move this 3x plus 2 on that side. 3x plus 2 into dy by dx is nothing but 3 dy by dz, right, which we call 3 dy. Now similarly we can prove 3x plus 2 the whole square d square y by dx square is nothing but 3 into d minus 1 into d into y. And okay, till that much is only required here in this problem. So if I substitute the given things in the differential equation, legendary differential equation, it becomes d into d minus 1. Okay, 3 into d minus 1 into y firstly, then 3 into d y. Agree? and after this minus 36y equal to 3 into x. Instead of x, what we are going to substitute? Okay, here x we will substitute. Just observe, here it is 3x plus 2 equal to e to the power z. Agree? We are going to move the 2 on that side, e to the power z minus 2, and move the 3 in the denominator. So we are going to substitute x by this. That is the only trick. Okay, different thing in this question. So e to the power z minus 2 by 3 the whole square plus 4 into e to the power z minus 2 by 3 plus 1. If we simplify the things, what we are getting in this question is nothing but, here it will be, here what we are going to do, you know, if it becomes 3 square is nothing but 9. If we simplify them, they will cancel out with this 3 and will again become 3. So let me simplify this. If you simplify this one, okay, I am going to simplify because you might feel the difficulty in simplifying these things. Okay, so let's just simplify the things. Okay, we didn't did anything wrong, right? It will be 3 square, sorry, here it will be 3 square. It is a, okay, in this ax plus b the whole square, a becomes a square. Okay, so it will be 3 square. So here we are going to get 9d square minus 9d into y plus 3dy minus 36y. Here we are going to have 3 e to the power 2z, right? Then 4 e to the power z plus 4. Agree? Then after this we are going to have here plus 4 e to the power z minus 8 the whole upon 3 plus 1 will be as it is. So here you can clearly see this and this will get cancelled out, and here minus 4 will be left. So e to the power 2z minus 4 by 3 plus 1. Agree? And here if we simplify the thing, we are going to get, here it will cancel out with this and we are going to get minus 6, right? Here we have 3d and okay, here we forgot to write 3d. How? Because here it was already 3d was already there, and here there is 3, so we forgot to write the 3d. So we are getting 9d here. So here it will get cancelled out and we can take the 9 outside. So if I take the 9 outside, we are going to live with d square minus 4 into y equal to this thing. If we simplify, we are further left with d square minus 4 into y equal to e to the power 2z minus this will become minus 1, right? Minus 1 by 3. If I, okay, remember there should not be any constant term outside, you have to take it on the right side. So if we do that, d square minus 4 into y should be e to the power 2z minus 1 by 27. So we're getting this thing. Now if I try to get the complementary function by getting the auxiliary equation is nothing but m square minus 4 equals to 0, and this is very simple. You will get m2 comma minus 2, roots are real and distinct. Complementary function will be nothing but c1 e to the power 2z plus c2 e to the power minus 2z. You have to resubstitute the value of z, which is nothing but, z will be what? Here z is nothing but e to the power z, what you will substitute? 3x plus 2. So if you substitute 3x plus 2, c1 3x plus 2 the whole square plus c2 3x plus 2 power minus 2. Now for particular integral, it will be nothing but 1 by d square minus 4 into, if here we are having e to the power 2z minus 1 by 27. So we are having 1 by 27 outside, and we are having two equations. One is d square minus 4 into e to the power 2z minus the other one is d square minus 4 into e to the power 0z. Agree? Agree? Now what we are going to do here, in this we are going to directly substitute, but you know, if I substitute here 2, it will become what? 0. Now if I differentiate, it will become 2d. Agree? 2d. So let's just try to differentiate. 1 by 27 into, here we will multiply by z, and here 2d into e to the power 2z. Agree? Minus, if we substitute here 0, we are going to live with plus 1 by 4. Finally I will do what? I will do the integration of this, which will give me z by e to the power 2z will be still as it is, and here it will become 4. Its integration will be same, and in the denominator its differentiation will be done by 1 by 4. So we are getting this thing. Now we will resubstitute the things. 1 by 27, z can be substituted by log 3x plus 2, and e to the power z can be substituted by 3x plus 2 the whole square, the whole by 4 plus 1 by 4 bracket close. So we are getting this as our final particular integral. Now general solution is a combination of complementary function plus particular integral, which is a combination of, if we substitute the things, we are getting c1 3x plus 2 the whole square, c2 3x plus 2 power minus 2 plus particular integral. Particular integral is nothing but 1 by 27 bracket log 3x plus 2 into 3x plus 2 the whole square by 4 plus 1 by 4 bracket close. So we are getting this as our final answer. Now hope you have understand 3 problems, and there will be one more session on this legendary differential equation. Then we are going to wind up this topic, okay, and end the higher order differential equation with constant coefficient, and do the last topic, which is application of both the chapters, first and the second, okay, which was first order first degree ordinary differential equation and the higher order differential equation with constant coefficient. Okay, bye. Practice these problems and see you in the next session. Okay, bye.